Assalamualaikum and a very good day for our fellow friends and lecturers. So as a schedule, our group we will presenting the digital system, the group assignment. So my name is Anis Syakirin, which is my groupmate name is Aina Amani, Tanis anak lelaki Murugan, and Melanie anak perempuan J Jaya Sangka. I'm going to go through with the group assignment part 1. So before we start, I would like to have you an introduction. So digital design is defined as a type of a visual communication and that present information through digital interface. So beside that, in digital system, a binary multiplier, which is a combinational logic circuit, is used to perform the multiplication of two binary numbers, and these two binary numbers called as a multiplier and a multiplicand. In this system, we're gonna use Verilog. So what is Verilog? Verilog is a hardware description language that we use to model electronic system. So commonly we use in the design and verification of digital system circuit through simulation, timing analysis, test analysis, and for logic synthesis. Let's go through with the question part 1. The question need to design, simulate, and verify a fully parallel 6-bit by 6-bit unsigned multiplier digital circuit with 1-bit full adders and half adders as a building blocks. So this is the block diagram of the question part 1. So the schematic diagram, this is software schematic diagram. Then this project implements 6-bit by 6-bit multiplier by multiplying each bit of the multiplicand by each bit of the multiplier to form a partial product. So let's go through with the calculation table. So instead of using X and Y input output, we using A and B. So A is represent the bits of the multiplicand, B we represent as the bits of the multiplier. So yang down there we use X that represent the bits of the products. So the coding I will pass into my groupmate that is Aina Amani.
Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hello everyone. Okay, my name is Aina Amani binti Aznan. Okay, now today I will like to explain about coding for part 1. Okay, this part shown when you will facing your project with software which is ISA Z-Link. And then first of all, after you open this application, you have to create new project. Okay, and then after that you will new project, and then you have to choose where your file will be placed, whether the stock or document or others. And then the first of all, okay, we have to create a file for full adder. Okay, this is my coding, which is my input is A, B, C in, and my output is home and C out. Okay, and then after that you have to run your coding whether it is successful or not. Okay, this is my coding and already successful. Okay, after that also you create new, which is you double click on this and then new source. Okay, and we create new for half adder. Okay, this is my coding for HA, which is half adder, which is input A and B and output is sum and C out. Okay, and then you have to go to also same. You have to go to multiplier 6 by 6. Okay, this is my input. My input declare as A and B, and my output is I declare as a P. So wire declare from Y1 until Y4, Y84, and then we proceed. This is a row 1, row 2, row 3, row 4, row 7, row 5, row 6, and this is and the last row. Still have, and how to get implementation, which is this one. First of all, you have to go to implement designs. I don't know, you have to go to this one, right? So yeah, you have to go to RTR schematic, and then you run it into, and you will get a result as this. So yeah, for this one. So okay, I will show you again how to get this result. Okay, this is multiply 6 by 6, and then you go to RTL schematic, and then you choose start with schematic on a top level block. Okay, and then you put it, and then we get this multiplier 6 by 6, multiplier 6 by 6, and then your schematic will show that 2 input here and 1 output as a P, as our coding already setting. And then after that you double click on the middle of the block. Okay, yeah, this is shown the real schematic. So, and then how you can see the full, which is this one. Yeah, how the result is shown. Alright, Okay, that's all. And then we have to go to a test bench multiplier. Okay, so as before, same goes to before. You have to create a new okay, this part one. You have to create a new source, which is for test bench. Okay, this is my coding for test bench. Yeah, when input declared as A and B and output is P, so it shown this. Okay, repeat it. This is repeated call 64 and begins. And then you have to running it. Test bench. Okay, you will get a result for this one. Okay, this shows that. Okay, this show the result for test bench. Where is it? Okay, how it work? Okay, okay, this A and B is declared as input, whether we set for two input. So here A and B as an input, and then count is what we declare, and then the output is P. So for a clear view, we just have to convert this count ready to unsigned, so it will be more clearly. Okay, this is 1, 2, 3, 0, 0, 1, 0. It's shown a repeated statement, which is when once the answer or the result will be double or 2 times. So from this result, we show that 00001 with a 00001 input will be give 2 times for output, which is 12 bits. Okay, function. Okay, that's all for today. Okay, thank you for me. Thank you for part 1, and then we proceed to another part, which is a part 2. Okay, thank you everyone.
Hi, my name is Stanislav Morgan and my metric number is B0112200085. For today, I will present to you about part 2. So guys, I will explain to you about digital lock system by using student identification number. Design, simulate and verify a synchronous digital system that detects and recognizes your student ID as a password that can be used to generate an output signal. The student ID is entered to the system sequentially and synchronized to the master clock for a proper operation of the system. As I said earlier, we have two modules. That we need to really understand to start this project. For the module mode counter, we can see that we are declaring clock, enter, reset, count, access and alarm. Let us see for the first parameter. First parameter n equals to 4 means it's the total number of the count. Parameter width equals to the 2 because we are using the binary number 1 1 that equals to the 3. Means like we are using the 2 digit of number. For the input, we are setting the clock, reset and enter, and for the output, we are setting access and alarm. For the main part of this coding, we can see that I am using the always, if and else if coding declaration. So for the first and the importance coding are given to the reset that will be set alarm and count to the 0. Means like alarm is turned off and the count will be reset to the 0. We can see also here we have an access 0 and alarm equals to 1 if the count is exceeded to the 3 and the alarm trigger will be on. So now we are looking into the main part of this coding. The main part is the pretty easiest one because you are just setting the password to the password that we like. As in this case, we are using the B022110085, which is my student identification number for this project. So we are declaring also the reset, set password, password in, enter, access, count and alarm. So for the input, the reset and enter, we are triggering the reset to the 1 and the enter to the 1. For the input, we are also setting the set password, which is the password that we are using as a preset. Now we are seeing we are looking into the main part schematic diagram, which is our we can see the input here is the reset, enter, set password and the password in, and for the output we are using the count, which is we are using to count the limitation that student can have to access the password input system. And for the access, when they are accessed into the system, and alarm will be triggered when they are exceeded the 3 of the time given. So now we are seeing the schematic diagram in the bigger scales. Now we can see that from this module part, this is the password input that we can give that we are using the IC to the mode counter. We can see that we can count that here we have a B, 0, 2, 2, 1, 1 and 8, 5. So the password input are correctly synced, and we can see here it is going to the OR gate. For the enter and reset, we'll straightaway connection to the mode counter that will encounter the count, access and alarm. Now we are looking at the test bench module, and we can see here that the registration is registered to the reset, set password, password in and the enter. For the set password and the password in, we are using the 40-bit binary input. For the output, we are accessing the wire access. Wire 10 count means like 2-bit count, and the wire alarm. For the initiate part, we are starting with the initial begin, reset equals to 0, set password means the password that we set as a default password. So here I will be using my identification student ID number, and for the password in we are starting from the 0. means that we are starting the initial password input is the equals to the 0 and the enter equals to the 0. And now for the correct password, we are starting with the correct password. We will be seeing in the result soon. So we are starting to the 50 nanosecond. This is the nanosecond unit that we are given to the coding. So we are starting the 50 nanosecond for the password in, which is the correct password that we are set to the password set. So now we are testing for the incorrect password, and until we are going to see the correct password again. And we will initiate the reset. We are initiating the reset so that the triggered alarm will be turned off, and we can now put our wrong password and a right password again. Now what we are seeing here is the result output. Now I will be explaining about the result explanation in detail so that you can understand better from the waveform. Okay, as we can see at the left hand side, here is the enter, check, reset, set password, password in, access, alarm, and count row. Alright, for the section I've divided to the A, B, C, D, E, F, G, and H. Okay, for the first section, the A section, we can see that the student inserted the correct password corresponding to the set password that we have been set. The default password is the B022110085, which is the student ID. So if the student inserted the correct password, access will be granted, alarm will be turned on, and the count will be 0. For the B section, we can see that the student inserted the incorrect password and access was denied. Access was denied and the alarm turned off and the counting start to increase by 1. For the C section, we can see that the password is still incorrect, access was denied, and the alarm was turned off because of the student doesn't exceeded the 3 limitation that has been given. For the D section, we can see the student still puts the incorrect password, so the access is denied, but now the alarm was on because of the 3 limitation was exceeded, and now the count was old. The admin should reset the password or reset the system so that the password will be go to the default, access will be the default, and alarm will be turned off, and the count will start to reset to 0. We can see now the student was inserting the correct password and access was granted. You can see the access row, access was granted, alarm was turned off, and the count was 0. For the G section, we can see the student inserting the incorrect password so that the access was denied, alarm was turned off because the count wasn't exceeded the 3 number that given. And we can see on the H section, the password was correct, and access was granted, alarm was off, and the count was 0. So we can see here that this is all the possible outcomes that we can have in our system so that the student can put the password or insert the password correctly, or to save if there is any theft unlocked.
Okay, I'm Malini here will explain about the conclusion of this assignment. Okay, we have learned that Shilling Software ISC Project Navigator is suitable for beginners who trying to make coding, especially for Verilog and VHDL as first programming language. We also have done and completed this project by doing simulation, verification, and setting up the moderate complexity digital system. Students can implement the ideas through the guidance and notes given by our lecturers in the class. It is important to note that the outcome of the project before getting depth into the project, which is the input, outcome, and the progress. This project gives a good impact for students to report writing and presentation. End of the learning outcome, we learn to create coding and able to complete a project. Okay, next we also had learned that digital design is a type of visual communication that presents information through a digital interface, which is the medium through that humans interact with computers. Students also understand more deeply about this project through this assignment. Okay, finally, students can communicate effectively through report writing and oral presentation. Thank you.